Hello everyone, how's the audio? Can you hear me? What about now? Is it better? Is it better now? Screen good? Okay. Well, let's get started. I think we have how many? 7 students so far? So, how's the audio? Is it better now? Audio? Is it better now? Okay, great. Um, what I can do is I can. I think this is as good as it gets. I'm literally right next to the microphone. Okay, and I don't think I can get closer than this. Well, anyway, let's get started. So today we are going to go over assignment number 6. Okay. Assignment number 5, you need to design a state machine which has multiple state machines in it. Okay. So 4, it was one state machine. 5 was multiple state machines, and 6 it depends on your preference. You can do it in one state machine or you can do it in multiple state machines. Okay. So let's start with the description. So let's go to view learn. Let's look at description. So what you need to do is you need to design a circuit that will interface with the DE10 light 2D joystick. So on the DE10 light, there is a 2D joystick. 2D means two-dimensional, X direction and Y direction. Okay. When you designed the circuits, we would like to use the naming convention we have developed in class. For example, our reset is key 0. Our clock is clock number 1. Our outputs are hex 5, 4, 3, 2, 1, 0. So digit 4, digit 5, the digit 0, and you need to simulate the design, realize the design on the board, and then implementation is very important because you can test it. Okay. So this particular 2D joystick will give you 4 uh, digits output. Okay. We are going to use digit 3210. 0 means MSB, 3 means LSB, and we do not use 5 and 4. Okay. Alright, so in this case, you need to use X dimension only. So it is an X and Y. So for this assignment, we're going to use the X only. Okay. Alright, so if you are in reset, all the hexadecimal displays are off. Okay. And your movement must match the orientation. So what is orientation? This is orientation. So first, you put the board VGA connector facing left. Okay, and then the directions we're looking at is left is minus X, right is plus X, up is plus Y, down is minus Y. Okay, so this is the orientation we're looking at. So right now, you do not need to deal with Y, you need only to deal with X only. So we're looking at left and right. Okay. Alright, so how does this work? Very easy. Let's look at a demo. So on ULearn, there is a demo. So I want you to watch the demo now. It's about 30 seconds. So please go on ULearn and then watch this demo. And then we'll continue in a moment after you finish watching it. Let me know when you're done watching the demo so we can get started on time. Okay, great. So everybody's done watching. If you look at the behavior of the sensor, what it does is it takes the reading of the sensor for the X and Y and then convert that into digital value and give it to you. Okay. When you convert the digital value, it takes some time to do the conversion. Okay. So how much time are we talking about here? Now we're talking about milliseconds. Millisecond means you can get 1,000 readings per second, which is pretty fast. Okay. Now for our assignment, there's no need to do that. We're not going to run this 1,000, samples per second. It's way too fast. So what it does is it will take the analog sensor values and convert it first. And then when you give the command, it's going to give you the readings live. Okay? So when you start sending the commands, it's going to do the conversion on the fly and then give you the values back. And then you can do it for X direction and Y direction. For assignment number D6, we are going to deal with X only. Okay. All right. So let's talk about how this thing works. Okay. So this is orientation, right? So if you look at the video, when you tilt the board left, the values changes. When you put the board down stationary, you get some values. When you tilt the board right, you get different values. Okay. All right. So let's go over the property of these sensors. First, all readings or all measurements 16 bits. Okay, you only give you 16-bit values. You cannot say give me 8-bit value. No, you always give you 16 bits. Okay. Okay. All measurements are in two's complement format. Okay, well, two's complement. My God. Yes, two's complement. You learned that from the digital logic. Okay. So because you have two's complement format, you can represent both negative and positive values. Okay. So the range of these measurements is FFFF is not FF. 0000 is stationary. That means you're not moving anything. 8000 is the most negative, and 0FFF, I'm sorry, it's 7FFF is the most positive. Okay, so when you watch the video, when we tilt to the left, the reading is going to be more negative. When I tilt to the right, the reading is going to be more positive. Okay, so when you're not moving it, it's going to give you somewhere around 0. Now, these sensors were calibrated at manufacture. Okay. However, when you start using it, you need to do the measurement yourself. So, for example, ideally, if you're not moving the sensor at all, it's supposed to give you perfectly 0000. But from the video, you can see that it's not true. Why? Because there's always built-in errors for the analog to digital conversion. When you start converting values, you have built-in errors. And you learn that from your DSP class with Dr. Neiman. So what happens is, for these assignments, you are going to get the readings from the sensor as is. You don't need to process them. The only thing you need to do is to show them on the 7-7 display. Then, when you take the demonstration, you can get the idea where you stand. For example, in the video that I show you, when you're not moving the sensor, the reading is 0003 or 4. So that means that's my 0000 location. When you start moving to the left, you can see that the values start to go FF something. Okay, the more left you go, the more FF you get. Okay, if you move to the right, tilt right, you're going to get more positive. So you get 001, 002, 003, and 4 and so forth. Okay. All right. So before I move on, any questions? Before I continue, any questions? Okay, that's good. All right. So how does this work? Each measurement require one command. Okay, so if you want to take a measurement, you need to send in one command. When you send in the commands, it's going to give you the data as well. You want to take a new value, new measurement, then you send in the command again, and then it'll give you the same. They'll give you a different reading, depends on what you're doing with the sensor. Okay, so if you don't want any measurement, then you don't send any command. But for D6, everything is continuous. So if you go to you learned, I gave you the commands. Here are the commands. Okay, so there are 3 commands total. So let's start with command number 1. Click. That's command number 1. So let's zoom in. So this is the command. The first command is to power on the device. Okay, so let's look at what's the deal here. There are 4 signals we're looking at. The black is from state machine to joystick. So that means your circuit is controlling these 3 outputs. The 3 outputs names CS underscore lowercase n SCLK SDI. Now where do I get these names? Very easy. You go to the user menu. CS underscore n SDI SCLK. These are the names we inherit from the user menu, and then each one has a pin number. Okay, all right. So state machine controls 3 outputs: CS underscore n SCLK SDI. State machine reads 1 input SDO. Okay, so going back to the diagram here, so you can see that when you're not doing anything, CSN is equal to 1, SCLOT equal to 1, SDI equal to 0. Okay, if you want to send commands, the first thing you do is CS goes to 1 to 0. Wait a little bit, S clock 1 to 0. Okay, wait a little bit, you can read the data on the orange line. So it says capture data. So you capture here. After you capture data, you wait, then you can change SDI. So now the first value for SDI is 0. Okay, and then the S clock goes to 1, and then wait goes to 0, and then wait, then you can capture data again. While you're capturing data, you can change the output SDI. So here we're going from 0 to 0. The next cycle, you capture data, you change it into a 1. So the command for number 1, power on, is 0 0 1 0 1 1 0 0 0 0 0 0 1 0 0 0. These are the 16 bits you need to send in. While you're sending in the data, it's going to give you something in return. Okay. Now the good thing about the power on command is that it is not going to give you any data. Instead, it's going to give you some random numbers. So that's why I call it XXXX here. So these values, once you capture it, you don't have to process them. They do not represent any meaningful measurement. Okay? So your job is to implement command number 1. Okay? So let's look at command number 2. Alright, so command number 2 is to configure the communication. You can see that it's exactly the same format, but the value you're sending out is different. Before, it was 001011, but you're 01000. But command number 2 is 0011, 0001, 001, 0, but you're zeros. Okay? To configure the communications, the return value from the sensor is all XX. That means they will give you something random. You capture it, but you do not do anything with them. They're not measurements. Okay. So command number three. Command number three is going to be very useful because this is to take the measurement for the x-axis. Okay, you can see that to take the measurement for x-axis, it is more work. Why? Because if you count, not only you need to capture the random values, 8 of them, you need to capture 16 bits in measurement. And then the order they sent you is this order. They will send you 7, bit 7 first, then 6, 5, 4, 3, 2, 1, 0. Then they're going to send you 5, 4, 15, 14, all the way to 8. Understand? So when you take the command here, you have the measurements, but your state machine is smart enough to figure out, okay, now 7 goes here, 6 goes there, 15 goes there. So then you need to save these values. Once you save these values, you can show it on the display. So the next diagram is to show you the sequence of these commands you need to send out, which is this. So what you need to do is you need to send power on command, so the device is power on, configure the communication, then read the x-axis, update the 77 display, read the x-axis, update display, read the x, update display, and then this whole thing will just go in an infinite loop. So that means command 1, you send it once. Command 2, you send it once. Command 3, you send it forever. But between each command, you need to update the 77 display. The reason we do this is because you cannot update the display while you're sending the command. You can only update the display once you finish sending the command. Once you finish sending the command, you can have the new measurement. You can have the complete new measurement. While you are sending the commands, you get partial measurements because you get 1 bit at a time. You do not get everything at a time. You get 1 bit at a time. Understand? Okay. So your job is to implement command 1, command 2, command 3, and then update the display. Now, based on the previous experiment, D1 through D4, you have used the 77 display quite a bit. Okay. So once you finish that, power on, configure communication, read X, update display. That's the sequence you need to follow. But power on is one command only. Configure it one time only. But everything else is in a loop. Okay. Any questions so far? Okay, very good. So I give you this diagram is for you to look at. Okay, the sequence. Now, one thing I notice from this diagram is that when you have the state machine controlling outputs, you cannot change any outputs simultaneously. What I mean is when you are trying to change output CS from 1 to 0, S clock is not changing, SDI is not changing. If you want to change S clock from 1 to 0, CSN is not changing, SDI is not changing. Similarly, when you're changing SDI from 0 to 1, CSN is not changing, S clock is not changing. So that's the property you need to follow. You cannot change two outputs at the same time. Okay, if you do that, you violate the communication protocol. Okay, all right. So the next thing we need to talk about is how fast can you run this state machine. So from CSN going from 1 to 0, there are two states because the first state is CS equals to 1, second state is CS equal to 0. Okay, but from 1 to 0 transitions, you need to go to two states, from state 1 to state 2. So how long does it take you to go through these states? Now we're back to the x value and y value. Speed of state machines. X value and y value. Now, x value means how many states do you change every time you need to change the state. Very easy, 20 nanoseconds. Every time you want to change state, you can only change one state. So x is 20 nanoseconds. And y value is how often do you change state. In this case, 200 microseconds. 200 microseconds. So that means your state machine will change states every 200 microseconds. Each time you change states, it's going to give you one state change. So that's the x value and the y value. If you do everything properly, according to these diagrams, power on, configuration, read command, update the display, you should be able to roughly capture 40 measurements per second. 40 measurements. That's pretty good. Okay. All right. So that's why we determine the speed. Now, if you start playing with these values, if you start changing x to be a different number, then your design is not going to work. If you make the y values larger, so for example, if you instead of using 200, you use 400, that means the speed of your state machine will double. Sorry, the speed of your state machine will be half. That means you will, instead of getting 40 samples per second, you will get 20. Okay, if you make y value from 200 to 100, that means you're going to make at least 80 measurements per second. Okay, to me, 40 is good enough. Okay, 40 measurements is way beyond what we need for this. Any questions about these parameters? Is Corbin here? I don't see your name showing up on the chat. Is Corbin here? No, Corbin, you're not here. I don't see your name. All right. are we all set with these notes? Don't worry, I'll ask again. If he's here, he will answer. All right. um, to design D6, you look at it, you get one command, two command, three command, you need to implement. So based on D5, you can implement a state machine for each command, and then interact between commands to where to start the output and where to do the loop. Because the first state machine power on, you just do it one time, but power on finish, configure communication will start. When communication starts, you finish it, it will finish, and then the read X axis will start, and then the update display will start. So this whole thing is in sequence. So you can do each command as one state machine and then interact between them. Or you say, well, I'm lazy, I don't want to do four state machines. You can do one state machines. Will take care of everything. Now, of course, you can see that if you do one big state machines, there are a lot of states you need to deal with. And then if you make a mistake, it's harder to debug what's going on. Okay. So you can have two ways of implementing this. All right, thank you, Corbin. Design method one. One state machine per task per command. Okay. So four state machines. Design method two. One state machine for everything. Okay. So the good thing is if you do one state machine per task per command, you can debug each state machine separately. If you have one gigantic state machine will do everything, then it's harder to debug. But once you finish everything, it's one piece. It's very easy to read. Okay, and that's really up to you. You can use method one. You can use method two. There's no really good and bad. Each one has its own advantage and disadvantage. So you, student, can determine which method to use. That's up to you. There's really no credit penalty if you use this method one or method two. It's totally up to you. Okay? All right. So before we go into the template, D6 template, any question? Is Abdullah Agamdi here? I don't see your name. Oh, yes, I see you. Okay. You are the first few. Abdullah Agamdi, you're all set. Okay, so let's go over the template. This is just a template. I'm not going to give you the code. So we always have the reset, the clock. You have digit 1, digit 2, digit 3, and digit 4. 4 digits. Okay. And you have 3 outputs you need to control, which is CS_N output std logic. Okay? You have sclock out std logic. You have SDI, then you have input SDO. Okay, all right. So these are the ports you need to deal with. And remember, the digits are not binary outputs anymore. Those are 7-segment displays. So this is going to be your hex. I'll call it hex 0, hex 1, hex 2, hex 3. Okay? So let me fix this order. Hex 0 is the most significant. Hex 3 is the least significant. Okay? So this is what you have 0, 1, 2, 3. That's what we're using. We're not using 4 and 5. So they are off all the time. Okay? And here is the template. Now when you work with this, I recommend you not to attempt to complete everything on the first attempt. You're not going to. You should do it in piece by piece manner, meaning that try if you can implement command number 1. If you can, try command number 2. So you get one command done, the second command done. Then you can see that your circuit will go through command 1 sequence, then command 2 sequence. When you finish that, you try the command 3. Okay? So in that case, you're making incremental progress because it is pretty sophisticated state machine. Alright? So next thing is due date. Original due date was Thursday, April, I think it's 30th. Okay. Based on the work you have accomplished so far, I can see that you need to use more time. So I'm going to give you extensions on this. Okay. So I'm going to give you one more class to finish it. So that means instead of making it 30th, I'm going to give you Tuesday, May 5th, before class starts. Alright? So this is the old due date. This is the new due date. Understand? So you can see that I give you one more weekend to finish this. I think that's a significant amount of time to give you. And I can guarantee you, when you work on these assignments, you do not attempt the night before it's due to try to work on this. You're not going to get it done. Okay? It takes me about 1 day to finish it. So you multiply that by 2 or 3 times. You're talking about 16 to 24 hours of work. Okay? So if you try to push this out the night before, it's not going to work. Okay? Yeah. So what you need to submit, you need to submit the code, and then you can submit a demonstration as well. Okay? So in the video, you're going to show the until left, until right, you're going to change the reading. X only. If you change Y direction, nothing will change. Okay? And make sure that you put yourself into the video so you can see that it's yours. Okay? Any questions about the submission and then the deadline? Well, class, the template will be on ULearn. Any question about the assignment? You what sequence of ones and zeros you need to send out. And when you run the Modelsim simulation, you can see this. Okay? Alright? And then it's command 1, command 2, command 3, and then the sequence you need to go through. Okay? Now, updating the 7-segment display has nothing to do with the sensor. Okay? This is strictly to update the display so you can see the measurement live. Uh, the next topic I want to talk about is the corrupted project. Okay? Because I've seen many of you having the same issue. The problem I'm seeing right now is that when you start the project in quarters, you write down your code, you compile your project, you try to run some simulations, and then the simulation will not load. Okay? So the symptom is in Modelsim, commands will not execute. So you run your simulation tool, you will not execute the command for you. Well, the first thing is you need to make sure that you are in the simulation mode. So you are in the simulation mode, the command will not execute. For example, you want to add the waveform, you want to add the input to the waveform. You will not add. You just say that your simulations, your command is no good. So what do you do? Okay? So after looking at many of your projects, uh, I give the help, I realize this is the problem. Your coder's project is corrupted. Okay? So even though your source code is perfect, it's working fine, it does not load anything properly into Modelsim. The Modelsim tested database from quarters and then load it that way. So what happened is, how do you fix it? Create a new project, then copy source code to new project. So that means you take your old project, you don't deal with it anymore. You only need the VHDL file. So you create a brand new project, you create VHDL file, then you copy the content of the old VHDL file that you're trying to use, and then paste into the new VHDL file you created inside the new project. Because the new project is supposed to be clean. Then in that way, you can move on. Don't get stuck because of the corrupted project. I don't know how you corrupted, but it could be you did not close the project when you try to exit the same machine, not exit the virtual machine, or you accidentally close the virtual machine without closing quarters. The correct procedure is you save your project, you close your project, then close your quarters, then you shut down your virtual machine. That is the correct sequence. But many of you are not doing that, or you didn't do it on purpose, you did it by mistake. That could corrupt your project. If the project is corrupted, the database inside the project is also corrupted. So when Modelsim tries to read the database and then give you the simulation environment, you were not able to do it. That's what happened. Okay? So in the future, if you run into this issue, don't panic. Just start a new project and then copy the source code over. Then you'll be good to go. Okay? Any question? Okay. Well, E6 is the topic I want to go over today. Next class, we will go over the solution for midterm. Okay. All right. If you do not have any questions, uh, is the midterm a project today in the next class? What do you mean? Because the midterm is going to be, well, the midterm was last week, so this Thursday we'll go, next Tuesday, sorry, next Tuesday we'll go over the solution for the midterm, the answers for the midterm in class. But this assignment, D6, is not due next week. I figured, you, all right, 3055 midterm is today. Okay, yeah, 3055 midterm is today. I separate the 3035 and 3055 on purpose, so we don't have the same midterm on the same day. So Tuesday we have this class midterm. On Thursday we have the midterm with the other one. Well, the project is not a yes, the project was due today. Yeah, it's due today. That's the D5, right? That's the one you need to output all the letters, all the digits to a file, and then load it the VGA emulator so I can see you done the work. Okay. Which class are you talking about? We have D7 in both classes. If you have questions about this class, ask now. If you have questions about the next class, let's ask the question next class. Otherwise, it's very confusing. Okay. Yeah, D7 is the last assignment. The D7 is the last design assignment. Okay. But if you don't have any question about D6, well, there's no extra credits. If you can finish all this, you get good credits. The extra credit work is going to be you look at it, you get all these assignments. Okay, you can get it done, you get good grades. Very easy. If you cannot finish these, how do you expect you to finish the extra credit assignment, which is a much more difficult? Okay? No, I do not give you out any extra credits for all my classes. Okay? There's no need to do that because you're already very busy with these assignments. Why do I need to overload you? There's no point of doing that. Okay? I do not try to overload you. I give you weekly assignments. That's enough. You have other classes to take. This is not the only class you're taking. Okay? I cannot occupy 100% of your time. Yeah, spend some time on this assignment. These are more difficult than the previous one. Okay? In your previous assignment, you may have 8 states, 10 states. That's it. But this one, you can see that you have many more states you deal with. Okay, so that will increase the complexity. Okay, if you do not have any question about D6, you can exit the live.